Okay, welcome students. Welcome to Unit 7. We have proportions and similarity. Our objectives for this unit are to use ratios and proportions to solve geometry problems. Use proportions to identify similar polygons and find the scale factor between the two polygons. Use scale factor to find corresponding lengths. Yeah, you can read the rest. Okay. The first section, section 1, what is a ratio? Okay, a ratio is simply a comparison of two things. For example, the census was taken from 9,490 schools to discover how many girls were in soccer. They found that 309,032 girls, oops, that's supposed to be a girls, participated in the 2003-2004 school year. Find the ratio of soccer players per school. Okay, so we want the soccer players, which is 309,032, to schools, 9,490. Okay, then find the ratio. Okay, so this is players to school, and you can write it this way, or you could write a ratio this way with the one you want, the players per school, which is 9,490. Okay, so that was our first part. Then find the ratio of schools to soccer players. So we want schools to players, which would be 9,490 to 309,032, and we'd write schools on top and players on the bottom, which means we'd have 9,490 over 309,032. Okay, and that's simply it. That's just a ratio. And if we wanted to reduce it, we could simply divide it using our calculator. We would take 309,032 and divide it by 9,490, and we get about 32.5. So it doesn't divide evenly. You could always, they're both even numbers, you could divide them both by 2 and reduce as much as you can, but it's not really that important right now. We just need to know how to write the ratios properly. In a triangle, the ratio of the measures of three sides is 4, 6, 9, and its perimeter is 190 inches. Find the length of the three sides of the triangle. You're going to be doing an awful lot of these, okay? And here's the thing. It gives you the total. So we know if we add them all up, we're going to get the total. Now, I know I have a ratio of 4, 6, 9, which means I have 4 times something plus 6 times something plus 9 times something, because I don't know what that is, but I know that when I add it all together, I'm going to have 190. Okay? Whenever you're given something like this, a ratio of the sides of a figure, you just put an x next to them. So that's 10, that's 19x equals 190. And if we divide by 19, we get x equals 10. So it didn't want the x, it wants the length of the sides. So we're going to take that 10 and we're going to plug it back in. 4 times 10 is 40. 6 times 10 is 60. And 9 times 10 is 90. And if you add them all up, you will get 190. Ain't that nifty? Okay, what is a proportion? A proportion is simply comparing two ratios. Okay, two equal ratios. And you're going to use cross products to solve this. Cross products just means we're going to kind of do a butterfly thing here. I'm going to multiply the top of one times the bottom of the other, and then vice versa. So we kind of get like a butterfly thing here when we do it in in middle school, I always draw the butterfly thing. But these two numbers right here in red, these are called the means. And then these two numbers in blue are called the extremes. And to find the, to solve the proportion, you're going to take the product of the extremes equals the product of the means. So right now we've got 2 times 9, and it has to equal 3 times 6 in order for this to be a proportion. 2 times 9 is 18, and 3 times 6 is 18, so voila, we've got a good proportion there. The property of proportion says that for any numbers a and c, and any non-zero numbers b and d, that means that these two numbers cannot be 0. A over b equals c over d if and only if AD equals BC. Okay, if this were A, and this were B, and this were C, and this were D, this is, of course, AD, A times D, and this is B times C. Okay, so it's just saying that it works. And now we're going to solve the proportions, and all we're doing is we're cross multiplying. Here we have 3 times 75, and that has to equal 5 times x. Okay, and we have 75 times 5, which equals 375. Sorry, 300. I was doing it times 5. I meant 75 times 3. This is 225 equals 5x. Divide by 5. Divide by 5. I get 45. So my x is 45. Here we're doing the same thing, okay, except we've got a little more complicated. We're going to multiply these two, so I have 2 times 3x minus 5 equals 4 times negative 13. Okay, first I'm going to distribute. 2 times 3x is 6x, and 2 times negative 5 is negative 10, equals, and 4 times 13 equals 52, and this is negative, so I have negative 52. Now I'm going to go ahead and solve. I'm moving my numbers over. Plus 10, plus 10. I'm left with 6x equals negative 42. And if I divide by 6, I get x equals negative 7. Okay, and the same thing here. Negative 4 times 2x plus 5 equals 7 times 6, which is 42. Going to distribute. 4 times 2x is negative 8x. Negative 4 times 5 is negative 20, equals 42. And add 20, and 20. Okay, and I get 62 equals negative 8x. Negative 8x equals 62. Okay, so when I divide by negative 8, I get x equals negative 7.75. Okay, so all we're doing is cross multiplying on these problems. Proportions in word problems. Okay, sometimes we'll have word problems when we have to figure it out. A twin jet airplane has a length of 78 meters and a wingspan of 90 meters. A toy model is made in proportion to the real airplane. If the wingspan of the toy is 36 centimeters, find the length of the toy. Okay, I like these problems because this is, real world stuff. You could take the proportions of model cars or model airplanes or even Barbie dolls and see if they would make a real figure In fact, that's something I'm trying to plan on doing with y'all later on this week. Okay, so we set up our proportion. We have the two links, the plane and the model, and then we've got the two wingspans, the plane and the model. So the proportions we set up, if we have the plane over the model on one, we have to have the plane over the model on the other one. Okay, so we want its length. This is 78. And the model's length, let's see, toy model is made in proportion. If the wingspan of the toy, okay, we don't have the model's length. So we're going to put an X. The plane's wingspan is 90. And the toy's wingspan is 36. So we have 78 over X equals 90 over 36. And we're going to cross multiply. 78 times 36 equals X times 90, or 90X. Okay, 78 times 36 is 2,808. That's going to equal 90X, so I'm going to divide by 90. I get 31.2. 31 equals X. Okay, so the plane's length, or the model's length, is 31.2 centimeters. Now, would it matter if I set it up this way, with the plane's length over the plane's wingspan equals the model's length over the model's wingspan? Well, let's see. The plane's length is 78, and the plane's wingspan is 90. The model's length, I don't know, and the model's wingspan is 36. Well, I still have, when I cross multiply, 78 times 36 and 90 times X. Okay, so I still have the same thing. So it doesn't make a difference if I want to have all of the plane with the length and the wingspan, and then all of the model with the length and the wingspan, because they're still going to be set up exactly the same. When do we use proportions in real life? Well, we've got art and architecture. And remember this word, because this is the word you're going to write down on your homework assignment to show that you actually watched the video. All right, and finding heights or distances, we can use mirrors. We can also use the sun to find our shadows. That's an interesting thing we're going to do sometime when it's not raining. And to see if things are real or fiction. Like I said, the Barbie doll, if the Barbie doll, if her proportions were the same as a real woman's, would she be real? No. Interesting fact, she'd have feet the size 4 and her legs would be way too tiny, so it would just be terrible. And the question for you to do on your homework sheet: our survey of 1,000 households, 460 had at least one dog or cat as a pet. What is the ratio of pet owners to households? Okay, so I want the pet owners to the households. You could write it like this, or pet to households. All right, that is your assignment, and have a great day.